Welcome everyone to the first episode of the Zero Knowledge Podcast. I'm Ihor.
And I'm Kirilla. We are co-founders of Yakisno LLC, company specializing in developing blockchain and AI solutions.
In this podcast, we aim to demystify technologies specific to blockchain, AI, and the tech industry in general. In this episode, we will cover zero knowledge proofs and explore their crucial role in the world of blockchain. We'll be diving into how they work, their applications, and why they're so important.
Let's get started. Yeah, zero knowledge proof is a fascinating aspect of cryptography that allows one party to prove to another that they know a value without revealing any information about the value itself.
So, Kirilla, how did you first come across zero knowledge proofs?
Yeah, it's a good question. It was like in our early projects at Yakisno, and we were developing a security application for our clients, and that's when we stumbled upon zero knowledge proofs and realized their potential.
Yeah, that's right. That's actually what's led us to start this podcast. We want to share our knowledge and insights with you, what we found during our investigation and implementations.
Yes, make sure to subscribe, leave us a review, and follow us on social media to stay updated. So let's dive in, Ihor.
Yeah, let's go. So today we'll start with the basics. This concept is incredibly powerful for privacy and security, especially in the blockchain world. But how did this idea came about?
I can add to this one, and it was started in 1980s by researchers Goldwasser, Mikali, and Rakov. So they wanted to create a way to prove knowledge without revealing the actual information. So they were looking for ways to ensure the privacy and security in digital communications, and their work laid the foundation for the development of zero knowledge proofs as we know them today, basically.
Yeah, it's really amazing how such an abstract and core concept can have many practical applications.
Yes, and this is especially important in our current state of the digital communications and market in general, when we have data privacy as a major concern within like every topic we are working in and live in. So yeah, and zero knowledge proofs offer a way to maintain such a privacy while still ensuring the integrity and authenticity of information. So, but yeah, they rely on some fascinating mathematical concepts. It can be hard to understand from first glance, but don't worry, we'll break them down and make them easy to understand for you. Right, Ihor?
Yeah, sure. So at the core of the zero knowledge proofs are complex mathematical structures like number theory, cryptographic algorithms, and probability theory. And one of the key concepts is the notion of a witness. In the context of zero knowledge proofs, a witness is a piece of information that proves that the prover knows the secret value without actually revealing it.
Can you show an example to our listeners, please?
Yeah, sure. So to illustrate this, let's consider a simple example, the Sudoku puzzle. If I complete a Sudoku puzzle, I can prove to you that I've solved it without showing you the solution by demonstrating that each number fits correctly without revealing the whole grid, but only a couple of columns.
Yeah, that's thank you for that. And this one actually is a real simple example. So let's talk about some specific types of zero knowledge proofs. It's zk-SNARKs, which stands for zero knowledge, succinct, non-interactive arguments of knowledge. So zk-SNARKs are incredibly efficient because they allow the proof to be verified quickly and without interaction between the prover and the verifier. So this makes them ideal for blockchain and privacy applications that actually popular these days.
Yeah, I agree. Let me add a couple of words about zk-SNARKs, which stands for Zero Knowledge, Scalable, Transparent Arguments of Knowledge. They are designed to be more scalable and transparent, making them more suitable for large-scale applications.
Yeah, and as I'm not that expert in this field as you are, could you please help us understand the key mathematical principles behind this zero knowledge proofs, like for me and our listeners?
Yeah, sure. At the very high level, zero knowledge proofs relies on complex mathematical constructs, also known as cryptographic primitives like elliptic curves, polynomial commitments, and hash functions, basically cryptographic strong hash functions. So these tools allow us to create proofs that are both secure and time efficient.
Oh, yeah, thank you for that. And could you provide like some specific example to illustrate how this principle works? Because like I can understand these concepts, but how we combine them together to get actual zero knowledge proof?
Well, I think the best example correlated with this mathematical concept is a discrete logarithm problem. So it's a pretty fundamental problem in cryptography at all, where you have a number, cg, raised to power x to get another number, y. And this can be used in zero knowledge proof by proving you know x without revealing it involves creating a zero knowledge proofs, basically.
Yeah, thank you for that. And I think yeah, it's clear for now.
Yeah, so I think we could move to the real world applications of zero knowledge proofs in the blockchain space and at all.
Yeah, sure. Let's do that. And so zero knowledge proofs, they're not just theoretical, and for now they are being used in various practical applications to ensure the privacy, security, and scalability as well. So let's dive into like more specific examples. Do you have any on mind, Igor?
Yeah. So, on my point of view, the most prominent uses of zero knowledge proofs is privacy preserving cryptocurrencies like Zcash. Zcash uses a type of zero knowledge proof called zk-SNARKs to allow user transact privately. And in Zcash, zk-SNARKs are enable shielded transactions where transaction details such as sender, receiver, and the amount are hidden while still being verifiable on the blockchain, actually. So I think it's like the most wonder of the zero knowledge proof when you could approve or verify the transaction, but without knowing such essential and privacy details like receiver, sender, amount, origin, and stuff like that.
Yeah, I know that Monero is working in similar to that was Tornado as well. It's kind of a crypto mixer that is banned right now by the governments. So yeah, and another exciting application is the field of identity verification. So you can use zero knowledge proofs to verify identities without exposing sensitive personal information. So, for example, you can prove you are over 18 without revealing your exact birth date or even your name. So, and I think this is crucial for protecting privacy, personal data, and especially in digital interactions when you have to prove you're over 18 online. Yeah.
Yeah, I agree. Especially today in a modern digital society, like after COVID, when half of the world starts to build their processes with the remote integrations, like with the help of this information internet systems, and without any physical meetings, any physical interactions. Just like via the cable. Actually, let's move forward, and it's also worth mentioning about ZK rollups. It's a layer 2 scaling solution for Ethereum, and the ZK rollups bundle many transactions in a single proof, which is then verified on the main Ethereum chain. It significantly reduces the amount of data processed on the blockchain itself. It's improving scalability and reducing transaction costs. I think we could dive into another example. Kirilla, could you tell us about the Aztec protocol?
Yes, actually, Aztec protocol and zk rollups, they were so popular this bull run. You can watch those technologies for a future. And the Aztec protocol is a privacy layer for Ethereum that uses zk-SNARKs to enable confidential transactions. With Aztecs, user can make private transactions, shielding the amounts and participants involved. Do you have something similar in your experience, Yor?
Yeah, I think I have one project I worked on that was integrating with that case SNARKs into a supply chain management system. So the goal was to allow different parties, different vendors to verify the authenticity of goods without revealing any sensitive business information. And this grant a huge increase of the trustworthy into the business sphere. So yeah, we worked on this kind of practical usage of zero knowledge proof and basically zk-SNARKs.
Wasn't it related to Diamond's supply chain project?
Yes. This was a project in the diamond industry. Basically, they have the major concern is about how to verify the quality of the diamond without actually seeing this. So before such project and basically our project, the people, the diamond experts should travel a lot, should see those stones personal. And with the help of zero knowledge proof and digital authenticity certificates, and this allows the expert to be more disconnected from the actual physical stones.
So it's sounds like a game changer for such industries that rely on this confidentiality and authenticity. Good example for real world application, actually. It's not just in web, for example, but it as well in offline world when you can combine this supply chain and the actual products or item with this technology.
Yes, for sure. So by using zero knowledge proof in this project, we were able to create a system where each party could prove their part of the process without exposing proprietary data. And this not only enhanced privacy, but also built trust among all participants. So yeah, I think it's some kind of a game changer, but it's need to be developed more and to integrate more widely into real physical businesses, not only in some high-end advanced IT businesses, but in some old physical businesses.
Yeah, it's still an emerging field, and we are getting trust to this. We should have many real-world application proofs that it actually works and works successfully. How can zero-knowledge proofs enhance privacy and security in the blockchain space? So because those are crucial aspects of blockchain technology, and I know that zero-knowledge proofs play a significant role in achieving them.
Yes. So let's start with the privacy. Zero knowledge proofs allow users to prove the validity of a transaction without revealing any details about the transaction. This is practically important in financial transactions and personal data protection. For instance, in typical blockchain transaction, all details are visible to anyone who accesses the blockchain. But with the zero knowledge proofs, we could secure sensitive information like transaction amounts and parties involved and stuff like that.
As I understood, you're talking about the concept of shielded transactions, which we touched on earlier. Is that correct?
Yes. This is about the shielded transactions mostly.
So shielded transactions are used to hide transaction details while still ensuring their validity. I'm not sure about security in general. So how do zero knowledge proofs contribute to the security of these transactions, basically?
Well, zero knowledge proofs enhance security in the global interactions. So zero knowledge proofs enhance the security by enabling a trustless transaction. This means that parties can interact and transact without needing to trust each other on a central authority. Like the proofs provides a way to verify transactions without revealing sensitive data, and this opened the doors to the peer-to-peer interactions basically.
Yeah, you don't have to know some like approval instance for you, so to verify that, like case of diamonds, that these diamonds actually are genuine and this transaction represents actually these diamonds. But let's not forget to mention another important aspect is regulatory compliance, because they mentioned earlier, for example, Tornado. They're banned in the US and in Europe, and they can't actually improve their protocol. So this is a bit tricky concept and sensitive as well. So, but still, zero knowledge proofs in essence can help to comply with regulations without compromising user privacy. It's like on the other side of this coin. So this balance is crucial for the adoption of these technologies. For example, in the financial sector, these proofs can allow institutions to prove compliance with anti-money laundering regulations without exposing individual transaction details. So they can mark a transaction that is not valid for AML, but still they don't know like who was sending it and what was sent inside of this transaction.
Yes, indeed.
I actually remember that you led a similar project on this topic. Is that correct?
Yes. One of the projects that I led on involved using zero-knowledge proofs for secure voting system. This is actually a very huge topic, but nowadays it didn't gain so much practical applications for now, but it's really fast growing and lots of even states working in these directions to build like secure voting systems. So by using this technology, we were able to create a system where the votes could be verified, but without revealing who voted for whom. And this basically ensures both the privacy of the voters and the integrity of the election.
Yeah, it's kind of a future aspect of secure and transparent elections. I heard like many countries working on that, but they are on stage of researching this field, building standards and probably infrastructure and rules how these systems should work. But still, it's the future, I think, of transparent elections.
In my point of view, yes, because zero-knowledge proofs were able to ensure that the voting process was both secure and private. And this actually, again, in my point of view, might solve a major concern in digital voting system. And this is the next step into the future where we could vote in our smartphones without like any extra steps. That's dramatically increase, I think, the speed, the agility of the states and agility of the social at all. So yeah, I think it's kind of a future.
Okay. And let's talk about difference between two protocols we talked about this whole time. So zk-SNARK and zk-SNARKs. What is the main difference between those?
One of the key differences is that zk-SNARKs do not require trusted setup. This means they can be generated without needing a security initial configuration, making them more robust against certain types of attacks. So their key difference is that zk-SNARKs is more efficient and zk-SNARK is more secure, but it's only in some kind of setups. So generally they both secure, but if you need like a more advanced security, you should choose zk-SNARK.
Yeah, but they kind of slower a bit, is that right?
Yeah, that's a trade-off. So you gain more security, but you pay for it with the speed of transactions or total the speed of the system.
Okay. And what about underlying mathematical principles that differentiate these two protocols?
Well, in short, zk-SNARKs rely on elliptic curve cryptography and require trusted setup phase and in contrast, zk-SNARKs use hash functions and do not require a trusted setup. This difference in cryptographic primitives is what gives zk-SNARK their scalability and transparency. So it's like in general well known that elliptic curve cryptography requires like more steps and more computational power to count to find the exact needed elliptic curve function basically, and hash functions in nowadays are a little bit more developed, and we built a little bit more perfect frameworks and algorithm on top of the hash functions. So this difference in cryptographic primitives is what gives zk-SNARKs their scalability and transparency.
Okay, and stepping back to trade-off between speed and efficiency of security system, can you elaborate on this topic? I heard you have a research on that, so could you please tell us more?
Yeah, so basically what I've said and what I found in my research that zk-SNARKs are excellent for application where efficiency and speed are paramount, such as in private transactions for cryptocurrencies. And on the other hand, zk-SNARKs are better for suited applications that require handling large data sets and complex computations, such in decentralized finance and large-scale smart contracts.
I will use zk-SNARK when I'm handling large-scale databases, and zk-SNARK when it should be small and fast. Good research, by the way. Thank you.
And one more thing is about ZK rollups and their significance in enhancing blockchain scalability.
Yeah, scalability is one of the biggest challenges facing blockchain technology today. Remembering NFTs in a Bitcoin network, their transaction cost became higher. It's a major concern in that field. And can ZK rollups offer an exciting solution to this problem?
Yes, so I think ZK rollups is exactly what we need in order to increase scalability for the blockchain at all. In simple terms, ZK rollups bundle many transactions into a single proof, which then verified on the main blockchain. And this significantly reduces the amount of data that needs to be processed on-chain. By aggregating multiple transactions into one, ZK rollup can increase transaction throughput and reduces fees and making blockchain networks more efficient. So like basically the main blockchain who verify the transactions don't need to know about all of the parameters inside those transactions, so it need to process less data, and as a result a blockchain process much more transaction in one step.
It's similar to layer 2 solutions, as I understood.
Yeah.
Okay. And I heard that one of the most notable projects on these topics that's utilizing ZK rollups is Loopring. So for those who don't know, Loopring is a decentralized exchange protocol that uses ZK rollups to enable this fast and low-cost trading on the Ethereum network.
Yeah, and I have another great example I can give is zk-Sync. It's also a layer 2 scaling solution for Ethereum, and that leverage ZK rollups to provide faster and cheaper transaction while maintaining the security of the main Ethereum chain.
Yeah, it's kind of clear for now that those projects have the potential to revolutionize the way we think about scalability in blockchain. But how do they work under the hood?
Well, let's see. So ZK rollups use zero-knowledge proofs to generate a proof that multiple transactions are valid. So this proof is then submitted to the main blockchain, where it can be verified quickly and efficiently. And this process offloads much of the computational work from the main chain, actually improving overall scalability.
Okay, let's dive into more technical details. Can you please explain the key components of ZK rollup?
Sure. So ZK rollup consists of several key components: the contract, the aggregator, and the zero-knowledge proof system. The contract manages the state of the rollup on the main chain. The aggregator collects transactions and generates proofs. And the zero-knowledge proof system ensures that transactions are valid without revealing any details.
One more exciting startup is Matter Lab, the team behind ZK Sync. So it's been gaining a lot of traction due to its ability to increase transaction throughput and reduce costs.
Yeah. I also know that there's a lot of startups over there working on zero knowledge.
Yeah, and there are not only startups, but like developers around this and customers of those solutions. You can go on DeFi Explorers and see the volumes and value locked in those protocols. It's a bit high. Let's talk about the community around this topic.
Yeah, I think the community is pretty vibrant with many resources available for learning and collaborations. Platforms like Reddit, Stack Exchange, and Ethersearch are great places to ask questions, to share knowledge, and to stay updated on the latest developments. For those who looking to deepen their understanding, and there are several excellent books and courses on cryptography and zero knowledge proofs. I could recommend a couple of books. Basically, it's Introduction to Modern Cryptography by Jonathan Katz and Yunda Lindell, and of course, Applied Cryptography by Bruce Schneier.
And looks like it is only the beginning for this technology.
Yes, and it is exciting.
It's hard to believe we are already at the finishing part of our first episode. So probably let's recap some of key themes and topics we've covered.
Right. We have explored the basics of zero-knowledge proofs, delved into their mathematical foundations, examined their real-world application. We also started by introducing the concept of zero-knowledge proofs and explaining their importance and enhancing privacy and security in blockchain.
Yes, we covered specific types of zero-knowledge proofs like zk-SNARK and zk-STARK, the difference between each other, and how they are being used to solve scalability, privacy issues in blockchain networks.
And we not to forget to mention innovative projects and startups that are pushing the boundaries of what's possible with zero-knowledge proofs. Reflecting on this episode, one thing is clear. Zero-knowledge proofs are a powerful tool that's driving significant advancement in the blockchain industry, and not only in blockchain industry. The potential applications are vast, and the community is supportive.
Yeah, it's correct. And remember that this episode has only scratched the surface. And there is so much to explore about this topic. So we'd love to hear from you, dear listeners. What topics did you like the most? Are there any specific areas you'd like us to dive deeper in future episodes?
Yeah, feel free to reach out to us on social media and leave a comment under this podcast. Your feedback is crucial and it helps us to create the content that's relevant and engaging for you.
Yeah, I agree. Without the feedback, we can't become better.
As we look ahead to the next episode, we are planning to dive even deeper into the world of blockchain and, of course, into the artificial intelligence technologies. And we'll explore new topics and emerging trends. We'll bring you more cases, studies, and practical insights.
Thank you for being the part of our journey this episode.
And until next time, stay curious and keep exploring the world. See you.
Bye for now.